Mercedes have got such heritage. There's not so many people that can genuinely take Formula One and bring it from the racetrack and look to put it into something that would be worthwhile on the road. The rear of the car is very familiar for Formula One. The power unit, as we call it. The engine, battery, power electronics, electric motors and the turbocharger. Exactly as you'll see in Formula One. At the front of the car, in Formula One, there's no electric machines. To give one the performance that we are targeting, that's where we've then put the electric machines to supplement what the power unit is providing by adding the extra power at the front. We really focused on how you get the absolute most out of that powertrain. It's not about compromising. It's about being creative, being innovative, without throwing away the performance, without causing other issues. And that was what we really had to focus on. The heart of the powertrain is a 1.6 litre engine. It's identical to what we see in Formula One. It's tiny, it's elegant, so it's the sort of capacity you would often see in a small family hatchback. And then we make that engine work to produce as much power as it can. One of the things we do is we turbocharge the engine. The turbocharger takes heat out of the exhaust stream and it turns a compressor wheel, which helps push more air into the cylinder. That lets us generate more power. Also within the turbocharger is one of the 4 electric machines. What that allows us to do is to recover electrical energy from the exhaust stream. What we can also do though is deploy energy through the same motor. And that means we can speed the turbocharger up in a way that makes the drivability outstanding. We've then got our second electric motor. In its own right, that motor is a 120 kilowatt motor. And what that allows us to do is recover energy or use electrical energy to boost the power that goes to the rear wheels. And all of this then comes down to how we manage the energy that's available. So the battery in the car is like a big buffer. It allows us to store that energy or to use it. All of these figures are stipulated by Formula One regulation. This is a finished Project One engine. We've got the base V of the engine, turbocharger in the middle, and the inlet systems at the top. This is a turbocharger assembly, and inside this is the turbine wheel. The whole thing runs over 100,000 RPM, and that assembly is then dropped into the centre V of the engine as we build up to get back to a finished engine. It really is a car of two halves. The Formula One power unit is so familiar at the rear, and then the technology from that we've deployed at the front. 120 kilowatt motors, one for each wheel, which gives us great flexibility because they're completely independent, they're totally controllable. So we can use those to drive in a high performance mode where we can deploy energy from the battery to the front and the rear. It can help with the handling of the car because you can control the motors individually as well at the front. Or you can drive in EV mode, where the front wheels will be driven purely from those electric motors. The software is immensely complex. In Formula One, it's much simpler. We've actually got a very, very simple environment. We know what a race driver wants. We know the circuits we go to. We know the characteristics. It's more complex in the real world because you have to cater for a wide range of drivers, a wide range of temperatures. Before we go out to run on a Friday or a Saturday or a Sunday in a Formula One car, All of the temperatures are brought up to what we call their phase document levels, because unless the water temperature is at a certain level, unless the oil temperature is at a certain level, we won't fire the car. All of that we have to engineer into Project One. We've got many, many electronic brains within the car, looking after the electric motors, the engine, the turbocharger, looking after the safety systems, and making them all work together is massively complex. The test bench is king. That's where we learn a huge amount. I've had test benches that are running 24/7 to just prove out new changes. We go from start to finish. And the mission is that we've understood how hard we can run the powertrain here in the factory so that we don't have issues at the track. But it's not a perfect science. We can't completely recreate all of the different duty cycles and use cases of different drivers and different environments. So the car learning from the development cars has been hugely important. We had a period of testing where the team spirit was brilliant. We had all of the key players in the team together. We had several cars there. We were testing in hot climates. The cars were being worked really, really hard, doing durability running, doing performance running, doing ESP tuning, which is where the powertrain just needs to deliver. So having seen it evolve to the point where we're then running in Strat 2, we've got all of the aero deployed, we've got full performance from the powertrain. The car pace around the track was just impressive. So seeing that, I was so pleased by it. Having a Formula One driver, David Coulthard, be able to tell us how well we've done our homework. Is that DNA still in there? Can they feel it? That's key. Because there's not many people that can say, I know what a Formula One car feels like. I'd love to say I do, but I don't. And it's emotional.
Congratulations.
Thank you.
I feel like a Grand Prix driver again. Nothing will ever put you back in the cockpit like this. Congratulations.
Thank you.
Now, if you don't mind, I just need to kiss the car.
Will it be the fastest in a straight line? Will it be the fastest on a specific circuit? Maybe not. But it is unparalleled in as much as the heritage of the Formula One powertrain and making it road legal. No other hypercar, certainly in the near term, will ever be able to say that. It will sit in there amongst those cars that people will say have truly been a milestone in automotive history.